Okay, guys, so we just saw how to solve a quadratic equations by taking square roots. We're going to solve quadratic equations by completing the square, and I'm going to jump right to it. So here we have an equation, y squared minus 8y minus 1 equal to 0. So what you want to do, remember that quadratic equations are in the form of ax squared plus bx plus c equal to 0. So what you want to do, step 1, you want to transpose your constant term. Transpose constant term, and that's my c term, right? So here we go. I'm going to transpose my -1 term by performing the opposite operation. And I did it to both sides in keeping with the law of equations. What you do on one side, you must do to the other side. So my new equation looks like this. And then the next step I want to do is I want to square. I'm sorry. I want to divide the coefficient of the second term. So I want to divide the coefficient of the second term by 2, then square it. So what I'm going to do, I'm going to take the coefficient of my second term. Now, if you look at previous videos, the coefficient is that constant factor of your second variable term. So basically, if we're looking at the formula base for quadratic equations, A are coefficients, B is coefficient, and C is technically a coefficient because this is really x to the 0, but x to the 0 is constant. So we don't really call constant coefficient because it's not multiplying any variable factor. So anytime you have a constant factor times a variable factor, that constant factor is called a coefficient. That's just a bit of a recap. So I want to take my coefficient of my second term, my b, and I'm going to divide that by 2 and then square it, which will give me a -4 squared, which is positive 16. And what I do with that, so this is kind of like a part A step. So B2 has two parts. You divide the coefficient of the second term by 2, then square it. And the next B term is then you add result to both sides of the equation. All right, so then I'm going to add the results to both sides of the equation. That's my 16. So let me just rewrite my equation in case, the words start and look jumbled. Are you not following? So here I go. I have my equation. I'm going to transpose my constant term. And this is my new equation. Then I'm going to take my second term here, which is the entire -8. Divided by 2 and square it, which would give me 16. And I'm going to add that to both sides of the equation. So my new equation looks like this. And I promise you that this expression on this side of the equation is a perfect square. So this is y minus 4 square equals 17. And if you don't believe me, I'll just perform a quick factoring act. Right? Remember, the leading coefficient here is 1, so I could just find factors of 16 that when I add them, I will get -4. It's positive 16, so an addition would occur to me to get my middle term. And remember, when you have a positive constant or a positive AC, depending on if your leading coefficient is greater than 1, if you look at previous videos on factoring, you'll understand the language here. Is that my factors will either be 2 positives or 2 negatives, and the middle term gauges whether those factors will be negative or positive. Since my middle term is negative, my end result have to be negative when I add. So that means I have to add 2 negative numbers to get a negative term. So here would be y minus 4, which is the same as saying y minus 4 squared. So that's how you always, whenever you're completing the square using this method, you'll always get a perfect square on one side of the equation. So now I'm going to use, as you can see, your knowledge is becoming cumulative because now you have to apply the rule where it says to solve by taking square roots. So I'm going to implement that rule here. So I'm going to find the square root of both sides. So here it is y minus 4 equal to plus or minus the square root of 17. And I'm going to add 4 to both sides to solve for y. So 4. So y is equal to 4 plus or minus the square root of 17. Let's do another problem. So here I have an equation where it looks like my c, or my constant, is already on the other side of the equation. So now all I have to do is find the coefficient. All I have to do is divide the coefficient of the second term by 2 and square it, which gives me 9/4. So my new equation looks, and then add it to both sides, right? So my new equation looks like this. And I promise you this is a perfect square. So this will be p plus 3/4 squared, right? Because remember, be able to find the square root of the last term. And this is, if I was to work this, evaluate this on the opposite side of the equation, I'll get 13/4. So now I'm going to use taking the square root of both sides to solve. So I have p plus 3/4 equal to the root 13/2, right? Because I can find the square root. Remember, the rules of root says that if you have the square root of a over b, is the same as saying the square root of a over the square root of b. So I was able to find the square root of 4 to get exact numbers. So now I'm going to subtract both sides by oh, I'm sorry, this is 3/2. 3/2. 3/2. Thank you for pointing that out, you math geniuses out there. No, it didn't look right for a minute. Oh, so now I have, apologies, p equals to negative 3/2 plus and minus root 13/2. So completing the square, the problems never look pretty, rarely. So don't be afraid when it looks like this. Just know that as long as you did the correct steps, you're on the right track. All right, let's do another one. Here we have an equation where they have the bx term on the opposite side of the equation. So we just got to bring it over. Don't let it intimidate you. So we transpose it, not actually bring it over. We transpose it by doing the opposite operation. And now we're going to follow through on the steps. So now we have a full equation here, quadratic equation equal to 0. So we're going to follow through by taking our constant term to the opposite side of the equation. So it's a little switcheroo that occurs here. And then we're going to find divide the coefficient of the middle term by 2 and square it. And then add it to both sides. So it looks like we have 25/4. I'm going to add that to both sides. I just set that up as a fraction. So we're going to evaluate it. It looks simple. So we know that this is going to be a perfect square. Well, actually, looky here. So I'm so glad I did this problem. Something I should have warned you guys is that you want the coefficient of your leading term to be 1 in order for you to create that perfect square, because you will not be able to generate a perfect square from this expression on this side. So let's redo this, babies. Let's start fresh. Here we go. So we have our equation x squared minus 3 equals to 5x. We agree that the constant term should be on this side and the x term should be on this side. But what I'm going to do, I'm going to make my leading coefficient 1 before I even take it there by dividing every term on both sides of the equation by 3, keeping with the rule of what you do on one side of the equation, you must do on the other side. So here we go. So I have now x squared minus 1 equals 5/3 x. And I'm going to transpose my terms as I mentioned earlier. So I'm going to bring my 5/3 x on this side of the equation, of course, by subtracting both sides, the opposite operation. And I'm going to add both sides, 1 to both sides equal 1. So this is my new equation. Now we're back in business. So here we go. I am going to take my the coefficient of my second term and divide it by 2, which produces a complex fraction, and square it. So your fraction game better be good here. So here we go. This is actually 5/3 times a half, the reciprocal, squared, which is the same as saying -5/6 squared, which is 25/36. Yes, 25/36. So like I said, don't be afraid of these numbers if they look uncomfortable, as long as you're following the right steps. So here we go. My new equation looks like this. X squared minus 5/3 x plus 25/36 equals to 1 plus 25/36. I promise you now we have a perfect square here. So this is x minus 5/6 squared equals to, if we were to find an LCM, this will be 36/36 plus 25, which will give me 61/36. Just in case you were wondering, I find the LCM here, which is 36. So we'll have 36/36, which is the same as 1. And now I'm going to find the square root of both sides to solve for my x. Plus and minus, and I demonstrated here that we can find the square root of 36 separately. And that will be 6, right? And then I'll add 5/6 to both sides. So x is equal to 5/6 plus or minus root 61/6. I promise you this is the solution. And if you don't believe me, here's the solution in your text. Ta-da! And the only reason why it's over 5 is because they share, over 6 is because they share the common denominator of 6. So you can write this also as 5 plus root 61/6. Oh, plus or minus. All right, guys, that's for completing the square. Whew, that was heavy.